So the demo I'm using is based on a workflow I first did about 4 years ago for a company that makes these pumps. And so there's thousands of components, and an engineer figures out from the RFP that comes in from the client how to configure this to make a pump. And then that then generates the bill of materials, which goes off to the people who do the manufacturing. They put the bits together and stick it on a truck. And as soon as the truck leaves the dock, that creates the delivery documentation, and then that triggers the finance app to do the invoicing. And all of this was done in Coda. And they're very happy with it. But
That's
this bit
amazing.
still is a manual step because it took an engineer with 4 years degree in engineering, and the reports, the engineering report that comes in is a human document. So the first point I make to people is that AI agents need to sit inside a workflow. And one of the reasons why people are scratching their heads and wondering, I can't figure out how to get this AI to work in my business, is because you're trying to get Claude Cowork to work in a vacuum, and it won't. It has to be embedded inside an existing workflow. And that workflow has to use your data tables and the capabilities that you already have. So let me do a go now and take a look at what it does. You're seeing it running in real time. And it's going through, it's doing the evaluate the pump engine. It has already done the evaluate the head race and all of this. So there's about 2 years worth of learning gone into this. For example, being able to take a huge amount of complicated information and represent it in a decision table, that was knowledge engineering at a very high level. This is 15 or 20 pages in a manual somewhere that a human would normally read. But when we got down to it and figured out, okay, how can we make this more condensed? It's the decision table, but it still has the fuzzy logic at the end. So it's not a formula, and it's not a table in the normal sense. It's saying a bit of this and a bit of that. And if you'd see this happening, then the word prefer, if this is the case, we would prefer this, unless there's some other reason why, and so everything's very fuzzy, which only an AI can do. So you get this big, long, complicated report coming in. We strip out all the formatting because the AI is much better with just plain text. And somewhere in here is the information you need in order to configure the pumps. Now, these are 6.5 tons of pump. They can empty a swimming pool in seconds. And what we have done is set up the system so that we have all of the information, the knowledge that is needed to make this work is stored in pages. So each page explains to the AI and is written by the human, this is how we configure the pump. And we start off by evaluating the head race, which is the water coming in. Then we build the pump, and then we evaluate the tail race, which is everything that comes out. And then we check for compatibility, because there's a huge number of rules about what's compatible with what. And if it isn't compatible, if the compatibility isn't there, then go and run this other skill called the backtrack. So a skill is a kind of super prompt. And so the big skill that kicks everything off is called configure the pump. And it says, here's how we configure the pump. So you go over here to Superhuman Go, and to kick it off, and then it says, when you receive Go, navigate to the schema page, then do this, then do that. And it says, now, and it's off to the races. So it says, I'm reading the schema to understand what the database is. Okay, I'm going to do configure pump. I've started configure pump. I'm running the skill called extract parameters, and the extract parameter says go through and find these parameters. But there's a kind of fuzzy thing in here. It says extract these parameters using the standard names, regardless of how they're labeled in the report. You can't write that in a formula. That has to be an AI that says, okay, so I'm looking for these things. Am I finding anything in the report that matches that? If I am, bring them. And it finds them here. So over in the log, it says, okay, we found the flow rate, the static head, and blah, blah, blah. It has found all these parameters. So it says, okay, I have everything I need. One of the things it looks for is to say, do I have a high level of confidence in how the parameters are configured, or are they a bit dodgy? And it follows different logic based on that. So now it's saying, okay, I'm now going to run the skill evaluate the head race. And the evaluate the head race says, here's the logic. And we use decision tables that contain all of the parameters that you need in order to configure these different things. So there's tables and there's text. And then it just goes through, and you can see here that it spent a long time evaluating lots of different things, coming up with different configuration decisions. It logs everything so we can go back, and if we end up in court because the pump was badly configured or something, we can present all of this as evidence to say, here's what it did. Now, one of the things that happens is this piece of text here says, when I look at the compatibility matrix, I chose the HR300 and the PE C30 and the TR2, but it's now telling me that the shaft seal is incompatible, the slurry shaft requires this type of housing, and the T2 pressure rating is insufficient, and so on. So it's come up with a compatibility problem, and it says, I need to backtrack. So it goes and it runs the backtrack skill, and the backtrack skill says, okay, figure out what do you think is the cause of the problem, use your clever AI magic and figure it out, and then go back and try a different configuration. So it does one attempt at a backtrack, and it says, okay, the next best match that I can find is the slurry rated discharge TR3. So it says, okay, I'm going to put that in, and then it goes and runs the compatibility again. And then when it runs the compatibility test again, it finds that the compatibility comes back as being legal. So it says, fine, I've got a legal result. So now I go and I run, it starts to run the build, the BOM, the bill of materials. So it builds the bill of materials, updates the database, and then reports back to say, that's it, I'm done. Now it logs everything in a history table here. So we have the exact timestamp, everything it did, and whether it worked okay or not. And if something goes wrong, it flags an error and will signal the engineers, because the engineers are all asleep in their bed at this stage. And this sends them a message saying, I've got something wrong here. Otherwise, they don't ever have to deal with it. And it stores everything in the data tables. So these are ordinary Coda tables. Here you'll see the task is complete. Here's the table that contains the parameters. Here's part of the configuration. Here's the bill of material. So these are just ordinary Coda tables. So the rest of the process carries on in pure Coda. It doesn't require them to have JSON. There's no packs. There are actually no formulas and no buttons. It is entirely run by what is written inside these documents, right? So everything is a page in Coda. And it's a page that says, here's how to do things. Now, the pages are written a bit like code, right? There's a while thing there saying, while this is true, keep doing this. It says, run this skill, which is a bit like a programming. It says, delete this, and so on. So we do have a pseudo-language. We call it SAIL, which is the structured AI language. And it says, we will say things like find for each, create, update, delete, navigate, log, if, while, and so on. We'll use uppercase for tables, we use propercase for columns, we use lowercase for keywords, and that's it. There isn't any formulas, there isn't any packs, there isn't any buttons. We've made this work using just these skills.